Good morning, everybody. Excuse me while I grab everything. Finish up our review today. I believe we've only got one more question left. And then we'll have our test tomorrow, and I'll be here. If you have any questions, need me help with that, you can always just let me know. It'll be just kind of like having regular class, just virtually. So I'll be here. I'm sorry for all the noise. I'll be here to answer your questions. I'm not really sure how we can do it because it's going to be everybody here. So whatever questions you ask, everyone will be able to hear, basically, that's on Zoom. So we'll just have to kind of see how it goes. But I just wanted to help you guys out if you needed help with anything. So that way you would have a good time for that. But let's just finish up. Let me grab the last question we had. It was another long question. All right, like I said before, throwing out a couple test questions off of your test, so you won't have to worry about that. Hello, TJ.
Hello.
We are just finishing up the review this morning. I think we only had one question left because we pretty much did everything else today. So,
okay.
I'm going to go ahead and use the whiteboard. All right. So this question is not on your review in the book. This is a question from your test, and it is a 12-point question. So we're going to
my.
And, I told Garrett yesterday, and I don't know if you saw it, but I'll be here to do the test tomorrow. So if you come to the Zoom class, you can ask me questions.
Okay.
If you need to. Okay. So I'm going to type out the question for you. In a calorimetry experiment, an unknown mass of glass, and then it's going to give me the specific heat of glass. At 90 degrees Celsius. So calorimeter, and then it's going to give me the specific heat of the calorimeter. Oops, sorry. Just want to type it out so you can see everything. And then it gives me the mass of the calorimeter. And it contains 75 grams of water. Gives me my temperature increase. Gives me my initial temperature to my final temperature. And then they ask us to find the mass of the glass. Okay, so just like we've been doing, this is our main equation. So energy released equals mass times specific heat times change in temperature. So in order to find the mass, I'm going to go ahead and rearrange this using algebra. So I'll divide this side by specific heat and change in temperature. So that's going to cancel and that's going to cancel. And I have to do the same thing on this side of the equation. It's a little messy, so I'll rewrite it in a second.
It's fine.
So it's going to end up being the mass is equal to Q divided by C times change in temperature. Space that out. This is the equation I'm going for, and they're asking for the mass of the glass. Well, I don't have, I do have the specific heat and I do have the change in temperature of the glass, but I don't have Q. So to find Q, I'm gonna need since I don't have the mass, I'm going to need to find the Q for the water and the Q for the calorimeter, and then find the Q for the glass. So we're going to start with the Q for the water. So we're going to use the same equation we started with. We're just doing it for the water. So the energy that the water absorbed. So the mass of the water is 75 grams. The specific heat of water you have to know is 4.184. Just plugging it in. And then the change in temperature in the water, it's going to be the final temperature, 26.6, minus the initial temperature, 24.3. And that's going to be in parentheses.
Okay.
Just grab my calculator. All right. So we're going to do 75 times 4.184 times, and then parentheses, 26.6 minus 24.3. And I'm going to get 721.74 joules. Okay, now I need to find Q of the calorimeter. Questions on how we found that one?
Yeah, the thing that's in parentheses right there, that is that where it says 26.6, is that minus 24 or is that just negative 24?
It is minus.
Okay.
Because when you do your change in temperature, you do your final temperature minus your initial temperature.
Okay.
All right, so let's find the Q of the calorimeter. Again, I'm going to use this equation that we started with before I rearranged it. So I'm going to plug in the mass of the calorimeter, which they tell me right here is 7 grams, times the specific heat, which they gave me was 1.23. See there, C equals 1.23.
Yes, I see it.
It's going to be the same change in temperature as the water, so 26.6 minus 24.3. Okay, so we're going to plug all that in. And I got 19 point, I'm going to say 80, and that's joules. Okay, so now I have Q of the water, Q of the calorimeter, and I have to use the other equation that we had in this module, which was negative Q of our object is equal to the Q of the water plus the Q of the calorimeter. So I'm just going to plug it in. So Q of the water was 721.74 plus 19.80. And that's going to give me negative, because there is a negative sign.
Yeah.
I'm just going to add it up.
Let's see here. Yeah, 1 second. Hang on 1 second. Sorry, my mom. Okay. Oh, you already got it.
Sorry.
That's fine.
So basically, whatever energy the water and the calorimeter absorbed is the energy. Q stands for the energy. Is going to be how much energy the object lost. So it makes sense that you're going to add them up. And it's going to be negative because it's losing energy. So now we have our Q. Now we can go back to this equation that we're trying to find the mass for the object. So I'm going to go over here and make some room. Just going to erase that. Okay, so now I'm going to go back to this mass equation to try to find the mass. So mass equals Q, which I just found right here. Just plugging it in. Divided by, And then in parentheses, I'm going to put C times the change in temperature. So the C of the specific heat of glass, I erased it, but they gave it to you in the problem. You just plug that number in. And you have to remember that your change in temperature for your object is going to be different than for your water because the object is starting at 90 degrees Celsius and ending up at 26.6. So a new set of parentheses, your final temperature minus your initial temperature. And then you're going to close both parentheses.
Okay.
If you want to plug it in, I'll wait and see what you get to make sure.
Okay, so seven, four. Okay. Okay. 33.29.
Okay, somehow you put it in your calculator wrong.
Really?
So that is not what I got. So in your calculator, it should look just like this.
That's what I thought I did. Should I try it again?
Yes,
Okay.
this should be your answer.
Let's see here. Okie dokie. Okay, there we go.
Got it?
Yes, 13.97.
And we have to round it to two significant figures. So we're going to end up with 14. And if I
Yeah.
add my units in here, this right here is joules. This here is joules divided by grams times degrees Celsius. And this is Celsius, both of these. So you'll see that your joules will cancel because one's on the top and one's on the bottom. Your your Celsius will cancel, and then you'll be left with grams. So that's your unit. You have 14 grams is your mass. And that would be your answer.
Okay, hang on.
Mhm.
Oh, 154. Okay, so All right. All those black lines in the problem are throwing me off.
Sorry, I was just showing you where everything canceled.
Okay.
All right, so 14 grams is the answer. That's the mass of the glass. And that was the last question I had for review. So luckily you're the only one here and you get to ask away if you have any more questions.
Lucky me.
Lucky you. If you want,
I'm sorry?
if you want to ask anything.
Oh, do I want to ask anything? Let's see. Yeah, so I mean, it's just like all these problems here. Like, this, as you know, this is like my first time being on one of these meetings again in a while, just because all my working hours have been in the morning, so I didn't really get to sit and watch, and I just forgot to watch them afterward. But these just, I think my biggest thing is these problems, like how you set up the problems. Like I'll just give an example, like for 12.5, if we look at that.
Okay.
Just trying to figure out how to set that up.
Okay. All right, so let's just do that one together. You only have 3 equations in this module. I'll go ahead and list them out for you. So you have Q, which is energy, we just said, is mass times specific heat times change in temperature. And then you have negative Q of an object is equal to Q of water plus Q of your calorimeter, and that's in a calorimetry problem. And then you have your change in temperature equation, which is equal to your final temperature minus your initial temperature. So these are the only 3 equations you're going to be using at all on any word problem here. So basically, okay, like I said, I guess you weren't here, but at the end of module 11, I talked a lot about just reading the question, figuring out what they give you, kind of make a note of what you have, and then looking at your equations to decide what do I need to use to find what they're asking me for. So let's just kind of go with that method for 12.5.
Okay.
Starts off saying a calorimeter holds 188 grams of water. Okay, well already it said calorimeter. So I know I'm probably going to be using this equation here at some point, right?
Yes.
So a calorimeter holds 188 grams of water at an initial temperature of 23.5 degrees Celsius. A 55-gram piece of metal at 100 degrees Celsius is dropped into the calorimeter, and the final temperature of the water is 28 degrees Celsius. What is the specific heat of the metal? Ignore the calorimeter in this problem. So like I talked about before, if they tell you to ignore the calorimeter, you just consider this value to be 0. So I already have this value. This value is 0. So I don't need to solve for the Q of the calorimeter. But I do need to figure out what they're asking me for. So they say, what is the specific heat of the metal? So C here is specific heat. So I know, first of all, I am going to use this equation. So let me go ahead and write it over here so that I can solve for C. This is just using algebra.
And a calorimeter, whatever you say, is how much heat an object's environment absorbs, right?
A calorimeter is used in an experiment to find out how much energy an object is releasing. So the calorimeter is like the container that's holding the water. There's a picture of it on...
Oh, I'm already on that, 434.
Let me get there. I have my book open. Let's see. You said 434. Yes, that's the calorimeter. So the container there. Okay. Yeah, it's an insulated container that holds normally water, but it can be any liquid. Okay, so I'm gonna solve this equation for specific heat because that's what they want me to find, which is C. C is specific heat. So I'm going to divide this whole side over here by mass. I'll type it out. Mass and change in temperature. That way, mass is going to cancel, change in temperature is going to cancel, and I'm going to be left with specific heat over here. And then I have to do the same thing to both sides in algebra. So I'm going to divide this side by mass times change in temperature. Sorry, you can't really see that.
It's okay.
I'm just going to put T because you know what I mean. Okay, so I'll rewrite out my equation. So C is equal to Q divided by mass times change in temperature. So this is the equation I'm going to end up using because they're asking me for specific heat. But I don't have all the pieces of this yet. I do have the mass. I do have the change in temperature, but I do not have Q. So I need to find how much energy my object released. Well, in order to find that, I need to figure out how much water absorbed and how much the calorimeter absorbed so that I can figure out the Q of my object. So first, we know Q of calorimeter, I just told you that's 0. So let's figure out the Q for water. So Q of water, same equation.
That dash right there where it says C equals Q dash M, is that just divide?
Division, yes.
Okay.
So I'm using the same equation up here. I'm just doing it for water. So now I'm just going to plug it in. So I'm looking for the mass of the water. How much, I just wrote it out. What did they tell you was the mass of the water?
How much was the mass of the water?
Mm-hmm.
I didn't see. I was writing, wasn't paying attention to that.
That's okay. You can look back and tell me because I want you to be able to set it up, you know, on your own.
188 grams of water.
There you go. So 188 is my mass. The specific heat of water you have to know by heart. So this number, you have to write that down somewhere in your notes to say C of water, the specific heat of water. Here, I'll write it out for you so you can write it in your notes.
Yeah, I see the chart on page 40, 430.
Okay.
Specific
You need
heat
to
of common
remember this value.
substances.
So I'm just plugging it in there. And then the change in temperature, I'm going to have to use parentheses because it's going to be the final minus the initial. So what was the final temperature of the water that they told you?
Let's see. The temperature of the water was 28 degrees Celsius.
Yes. And then what was the initial temperature of the water?
23.5.
Yes. So you're going to plug it in your calculator just like this. Let me know what you get.
Okay, so 188. 0. Okay. Okay, and it equals, I got 3,000, I don't know if you say 3,000, but 3539.664.
Good job. That is the right answer. That is how much energy your water absorbed. Okay, so now I have Q of water and Q of the calorimeter, so I can figure out the Q of the object now. So I'm just going to plug that in. Negative Q of the object is equal to Q of the water, which was 3539.664, plus the Q of the calorimeter, which they said to ignore, so that means it's just 0. So then my answer is going to be negative 3539.664, and I'm going to round that to 3 significant figures. So negative 3540. Whoops. And it makes sense because if your water absorbed this much energy, then your object had to release that much energy. So they're the same number. Does that make sense?
All right.
Now I have all the pieces that I need to solve for the specific heat of the object, which is what they asked me for. So now I'm using this equation right here. This one. All right, so we're going to start over here. C is equal to Q, which I just found here, negative 3540 joules, divided by mass. So what was the mass of the object?
The mass of the object, 55.0 grams.
Yes. Times change in temperature. I'm going to have to do the final minus the initial. What is the final temperature of the object?
Is it that problem right there? You just have to add it up.
No, they give you the final temperature in the word problem. And I will give you a hint. The final temperature of the water is going to be the same final temperature for the object.
Oh, so 28
Yeah.
Celsius.
And then minus the initial temperature. What was the initial temperature of the object?
23.5.
No, that was the initial temperature of the water.
Oh, I'm sorry. 100 Celsius.
Yes. Okay, so put it in your calculator just like this.
All right, negative. Divided by. Okay. Okie dokie, and we get 0.893.
Good. And we're going to just round that to 2
90.
decimal places. So
There
89.
you go.
That 3 is going to make the 9 stay the same. And then our unit is going to be joules divided by grams times degrees Celsius. So J divided by grams times degrees Celsius. That's our unit for specific heat here.
Okay.
Did that help you out a little bit?
Yeah, I think so. I'm just trying to write it out just so I can try and figure it out.
Yeah. It's a lot, but just look at what they give you. Remember, these are the only 3 equations, so that should help you. You can always rearrange them if they ask you for a different piece. You know, if it's not Q they're asking you for, if it's one of these, you just have to rearrange the equation, but still use the same one. You have anything else you need help with?
I mean, again, it's probably just how you're supposed to write down these different equations. Just because I wasn't really around to hear the full explanation of how you write them down.
All the videos are there on Homeschool Minder too, if you want to go back and watch, and they're all on my YouTube, my school YouTube. So
Okay.
if you need help. And I think I put in the description what they're covering. So like if there's a specific on your own question that you're looking for, I put it in the description, like what I cover in that video. So that way you can find it.
Okay. And this problem that we just did, when we do our, like, it's more to your, well, I don't know if it's your right or my left. Okay, so on my left and near the bottom is the Q object.
Mm-hmm.
And equals the 3, 5, whatever, and then the plus 0. Where's the 0 coming from?
So they said to ignore the calorimeter in this problem. So if they ever say
Oh yeah,
ignore
right.
it, then this value is 0 because it doesn't absorb enough energy to even make a difference in our equations. That's why they just tell us to ignore it.
Okay.
All right. Last call for questions.
Um, I mean, I don't know if it's just just figuring out how to write all the equations down. So that's not really. We went over that basically. So I'll just have to go back, rewatch, and try and figure it out.
Okay.
And
And
I started yesterday's review, by the way. I started watching the video. I didn't finish it all the way, so I'll just go back and rewatch that.
yeah, I would definitely watch that. I did, let me see. I did 1 test question today and I did 4 test questions yesterday on the review. And then for your study guide and practice problems, there was only like 6 that I chose to do that would be similar to questions on your test. So you don't even need to do the whole review that's in the book.
Okay.
So that's all there. And I'll be here tomorrow at 9 o'clock for the test. I'll text it to
Okay.
everybody. And then, if you have questions or whatever, like I'll be here live. So, and you can always, ask me questions through email or text if you take it at a different time. So,
Okay.
that, and trying to think if there's anything else. I think that's pretty much it.
Okay. Well, again, yeah, I'll just go over everything, make sure that I can understand it. I'll try and work on more of the actual big problems. And if I need help, I'll ask you tomorrow.
That sounds good.
All right.
All right. Have a good day.
You too. Appreciate it.
Thanks. Bye.